What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 2 in the 6th grade math questions that North Carolina released this past school year. The question tells us that Paul had a job during his summer vacation. He earned $8.75 per hour and he worked 20 hours per week for 8 weeks. And we're trying to figure out how much money Paul earned in total. So the two skills that we're going to need in order to be able to do really well on a problem like this are how to translate a word problem, and also we're going to have to end up multiplying a decimal number by a whole number. So this first skill is one that I've done in many other questions that I've done videos for. They should be filed with this playlist. And the second skill we haven't tackled yet if you've been keeping up with my videos on these questions, but we'll be fine. Alright, so I'm going to start with my translating bit, and I'm going to look at this word per, and then I see the word per another time down here. Anytime I see the word per, that tells me that I'm going to be multiplying. And since I see the word per twice, that tells me pretty reasonably that I'm going to have to multiply twice. Specifically, I'm going to multiply 3 numbers representing my wage, my hours, and my weeks. Alright, so now, wage times hours times weeks. $8.75 per hour is my wage. That's 8.75. He worked 20 hours per week for 8 weeks. And it's at this point, and by the way, $8.75, that's not too bad. Minimum wage is $7.25, so if you can find a job that pays $8.75 an hour, you could do a lot worse. But anyway, now that we have these 3 numbers and we know that we're going to have to multiply these, the big question is, which 2 do I want to multiply first? Because the nice thing about multiplication is that we can multiply any 2 of these first, and then multiply the third one and we'll be okay. I personally want, and I personally try when I do a problem like this, to multiply the 2 easiest numbers first. So in this case, that's going to be 20 times 8. 20 times 8 is the same thing as 2 times 8, and then we just tack a 0 onto it. So this would be the same thing as 16. Or no, sorry, I forgot to tack my 0 onto it. 2 times 8 is 16, we put our 0 on the end and we get 160. So now, I've got 8.75 times 160. And it's at this point that I want to talk about the big trick for multiplying decimal numbers. And that trick is, we start by counting our decimal places. I have 2 decimal places here, and so when I multiply these 2 numbers, and if I'm using the standard algorithm, this is the best way to go. If I multiply these 2 numbers, then I'm going to go ahead and do my multiplication like normal, and I will show how this can work with the box method, since I am sure that many of you will have seen that and might find that a little more familiar, but it is good to have multiple methods in your back pocket. So I'm going to treat this decimal place like it doesn't exist, and I'm going to multiply 875 by 16. So to start with, I'm doing, and let me go ahead and actually erase all this stuff, because it's cluttering up my workspace. So 6 times 5 is 30, also known as 0 ones and 3 tens. 6 times 7 is 42, plus 3 is 45. So that gives us 5 tens and 4 hundreds. 6 times 8 is 48, plus 4 is 52. And now I'm done with my 6. I'm done with this stuff. So I'm going to go ahead and cross this out and treat this like I'm multiplying it by 10. So I'll put a 0 down here. 1 times 5 is 5. 1 times 7 is 7. 1 times 8 is 8. So I come down here and I add all this up. My zeros give me 0. My 2 5s give me 10, also known as a 0 and then a 1. 1 plus 2 plus 7 gives me another 10, another 0, and another 1. 5 plus 8 plus 1 gives me 14. I bring this 0 down and tack that on the end. And here's when I come back to these 2 decimal places that I decided to ignore in order to make this multiplication easier, because I took these 2 decimal places off, but I have to actually put them back on the number, which means I'm going to go left from the ones place, 1, 2, and put my decimal right there. Now this has the benefit of actually looking like an amount of money. It actually looks like $1,400. I look at my answer choices and I can see $1,400. And now if I want to use the box method for this, then I'm just going to have to go ahead and get out my big board, so you'll see a cut as I'm getting that ready. So here's how I'm going to set up my box method. I have 800 plus 70 plus 5 and 10 plus 6. Once again, I'm not treating this like it's 8.75 or 8 7/500ths. I am ignoring my decimal places in order to make this multiplication a little bit easier. I am creating my boxes, and I'm going to go ahead and do all my multiplications. 800 times 10 is the same thing as 8 times 1, and I add on my 1, 2, 3 zeros. 10 times 70 is the same thing as 1 times 7, and I add on my 1, 2 zeros. And then 10 times 5, I know from times tables that that's 50. Now I come down to 6 times 800, which is the same thing as 6 times 8, with 2 zeros on the end. 6 times 7 is 42. I put my 1 0 on the end of that, and 6 times 5 is 30. And at this point, I'm going to take all these numbers and add them all up. 8,000, that is supposed to be an 8. 4,800, 700, 420, 50, and 30. I have only zeros in the ones place. 2 plus 5 plus 3 in the tens place gives me 10 tens, also known as 0 tens and 100. 100 plus 800s plus 700s plus 400s gives me 20 hundreds, also known as 0 hundreds and 2,000s. 2,000s plus 8,000s plus 4,000s gives me 14,000s. Once again, I remember to put my 0 on the end of that, because my original number was 160. And then once again, I need to bring back the 2 decimal places that I basically ignored, because my decimal was between my ones digit and my 10th digit, between the 8 and the 7. So I bring back my 2 decimal places, 1 spot, 2 spot. Even if I use the box method, I still end up with $1,400 as my answer. And a good principle to keep in mind here is that even when you're using the box method, if you take off zeros or decimal places, you still need to put those back on at the end. So even if your method changes, some of the little things you do to solve a problem are going to be the same.